Created 20 years ago, Franklin France has firmly established itself as one of the leaders in lightning protection. Due to its concept of a global approach to the phenomenon on the 5 continents, Franklin France is in complete accordance with the different national and international standards. Parallel to the growth and sophistication of electrical and electronical equipment, the effects of lightning have become a major problem and both a human and economic concern. In order to respond to a worldwide demand for protection against lightning strikes, Franklin France has developed a wide range of coherent products and services adapted to a manifold of applications from prevention to indirect and direct protection. Storm warnings, locating networks, lightning conductors for buildings and structures, lightning conductors for protection against the overvoltage of electrical equipment, electronics, computer systems, and telecommunications. The Franklin Group consecrates each year 5% of its turnover to research and development and works in close relationship with the largest national and international laboratories and institutions to define specific standards. Franklin France carries out its testing in its own laboratories as well as in the specialized ones of its partners, such as CEA, the French Atomic Energy Commission, and EDF, Electricity of France, the University of Singapore, or the Electric Power Research Institute of China in Beijing. It was thus that in 1986, this exemplified will of research drove Franklin France to create and develop the first meteostorm network in the world, a service of national lightning observation with a warning of alert in real time for prevention. More than 10 million data have contributed to the creation of the official density chart of lightning strikes in France. This network now covers Mediterranean Europe. Since 1986, Franklin France has been awarded a number of prizes for innovative technology. The group has quickly become the world reference in its sector of activity by using its know-how in the development of products continually with greater performance and originality, such as the St. Elmo Lightning Conductor, one of its star products. Lightning is a permanent, natural, and universal phenomenon. Its frequency and intensity vary according to latitudes. Every second, approximately 2,000 strikes of lightning are registered in the world. Atmospheric discharges originate from a type of storm cloud called cumulonimbus. The upper part of this cloud consists of positively charged ice crystals, while the base consists of negatively charged water droplets. Atmospheric turbulence generates a separation of charges, which in turn initiate electrical discharges between the cloud and the earth, thus lightning. In the evolution of the phenomenon, as the potential difference between the cloud and the earth rise, the base of the cloud emits an initial discharge called a leader. Its progression towards the earth is carried out by a succession of dozen-metered bounds. As it approaches the earth, the tip of the leader, or dart leader, which is highly charged, vertically generates a significant increase in the exhalations or released from the earth or structures once the sill of ionization from the air is attained. This is the crowning effect that transforms into positive ascending discharges called streamers. The earliest and fastest exhalation, or upward streamer, joins the leader to form an ionized canal where the cloud-earth charges are neutralized, creating the flash of lightning. In the space of 0.2 to 1 second, Several returning arcs can be exchanged at a speed of 10 to the 6th power meters per second. In this figure, we witness negative descending lightning, which is of the most common. Positive bolts of lightning, although much rarer, are nonetheless stronger and more destructive. The most efficient lightning conductor is one that protects as much against positive and negative lightning by creating optimal conditions of excitation. It must be the compelling point of impact and therefore preferential to all other elements within the protected area. From French technology, the St. Elmo lightning conductor with a piezoelectric exciter device was designed by Franklin France in cooperation with CUA and received the highest award for technological innovation in 1986. It consists of these three principal elements: a profile captive head, inalterable and a good conductor, structured to generate a forced air circulation at its tip with air intakes and peripheral ejectors. This is the Venturi system. A support pole of stainless steel or treated copper, of which the upper portion has one or more stainless steel emitter points inserted in an insulated sleeve. A transducer stimulator made up of piezoelectric ceramics pre-stressed in an insulating container combined with a reliable loading system. These piezoelectric ceramics are quite unique in that when there is a modification of pressure caused by stormy turbulence, the piezoelectric ceramics generate both positive and negative high-level tensions. The stimulator is linked to a high-tension cable at emitting points that, once stressed to their high, elevated level of potential, send out large quantities of ions. If we take the most common example, the negative discharge, therefore positive earth, we find that the positive ions are trapped on the internal wall of the head, which only allows the flow of positive ions that have been accelerated by the Venturi system to escape. The phenomenon is reversible. Numerous tests carried out in laboratories as well as on-site testing has shown and confirmed the advantages of the innovative technology of the St. Elmo lightning conductor. This conductor favors the increase of the local electrical field, the presence of seed electrons at the capture point, the creation of an ascending ionized air channel in the prolongation of the lightning conductor which allows intervention on, the shortening of the excitation lag, the initial condition of the triggering of the corona effect, the rising velocity of the corona discharge. Shock tests performed at the Bazet High Voltage Laboratory simulating lightning discharges showed evidence of the importance of the major enhancements in excitation of the St. Elmo lightning conductor in comparison with a simple rod. This advancement in excitation is the determining element of efficiency of the St. Elmo lightning conductor. In fact, the premature triggering of a streamer permits a faster interception of the leader, and from there it puts the point of contact at a further distance, thereby creating a greater range of coverage and protection by the St. Elmo lightning conductor. The St. Elmo lightning conductor is attractive with great performance, robust and reliable, and offers the reinforced safety of being permanently connected to Earth. It is user-friendly, completely autonomous, and it requires absolutely no maintenance. The wide range of efficiency of the St. Elmo lightning conductor permits the coverage of extensive open-air zones and complexes that traditional means couldn't offer. "40% of Franklin France's turnover comes from foreign countries. Tens of thousands of projects have been carried out in various fields of application throughout the world with the St. Elmo lightning conductor. Transport, with the Jakarta Airport and the Paris Charles de Gaulle Airport. Energy and environment, with Dow Chemicals in Mexico, Leona Brewery Factory in Colombia, and ELF in the Gabon. Military and civil protection and telecommunications, with the French Armed Services, France Telecom, and the Kourou Space Center in Guyana. Leisure, with a number of installations such as golf courses and Disneyland Paris. Historical monuments such as the Temple of Ayutthaya, Thailand, and the Universal Expo 98 in Lisbon, Portugal. Franklin France relies on and is dedicated to its experience and innovative philosophy so that with each and every new day, it's able to push forward in the mastering of this natural and fascinating phenomenon which for the moment is far from having revealed all of its secrets. Lightning.